Lesson 5 is all about printing and assembly. In this case, we have our clamp side top and our clamp side bottom that we're going to print out, and once printed, we'll assemble using the provided number 6 nut and bolt. Now, SolidWorks provides a direct to 3D print option that's found on the File menu. But there are a lot of 3D printers with unique drivers and softwares. Your printer may be networked or non-networked, so you may not be directly attached to a 3D printer, or SolidWorks may not be able to keep up with the driver changes that are occurring between printers. So each 3D printer manufacturer designs their own software to best control their printer. Now, take a moment and imagine how your career will differ from the lab you're sitting in. In your lab, you're sitting at a computer. You can probably see your 3D printer, but in an office setting, you may or may not be connected directly to a printer. You may have to save the file to some sort of flash drive and then go to a different floor or a different office. You may be sending this to a colleague at a different location who has different software. So you need a format that is portable, that any printer or any software can look at. This is similar to the way you might send a document through email or a spreadsheet, and the same way you might receive a document or a spreadsheet. Oftentimes you'll receive a PDF version, and that's because you can print that from any operating system or any printer. The most common file in design that is similar to that PDF type format is the STL file. If I go to File Save As from SolidWorks, and then I pull down on the Save As Type menu, you can see the option for STL right here. If I expand the Save As Type menu, you can see several different types of files that you can save as, from Parasolid to IGES files, and these are common files that you'll also see that can be read by most design softwares and printers. But the STL file is the most common, and we can see that it's located on the list right here. So to save a file in SolidWorks, first we'll select STL as the Save As type. And it will change the file name here from clamp assembly with your initials to .stl file extension. You'll want to save this in your student folder. And then before proceeding, we'll click Options to bring up the individual settings for the STL files. The main setting you're concerned with is the resolution. You have three options: coarse, fine, and custom. Currently ours is set to fine here, which basically gives you two options between coarse or fine, which coarse is going to mean basically rougher, and fine is basically going to produce a smoother surface, and custom is going to let you automatically set the different options for deviation and angle. Before we move on to custom, I wanted to point out the differences between coarse and fine as it pertains to a particular design. You don't necessarily need a simple shape, something like a cube, to be fine. It can be coarse and still be acceptable because it's a very simple angle. So if we see coarse, we see less lines here being used to create this spherical shape here. And if we go to fine, we see a lot more lines to the point that we really can't see any edges. But also consider what type of design you're printing. Sometimes coarse may produce a suitable model just for doing a rough edit if you're talking about a round surface, but also if you're using a basic shape like a square or a rectangle where you have very little changes, coarse may be suitable for a production prototype to evaluate. Now notice on custom, as I change the deviation and angle sliders, and you can see a more thorough description of deviation and angle in the student manual in lesson 5. As I decrease the deviation, we see a higher number of faces being used. And as I decrease the angle, you're going to see the changes shown here in the center shape, and that's increasing the detail. So, the coarse, fine, and custom settings give you complete control over the output resolution of the STL file. With regards to the 3D printer, you would generally want to send a higher resolution file. The 3D printer themselves are going to have controls and settings to control the appearance of the part, so you wouldn't want to control that from the SolidWorks interface. So again, we'll export out with the higher resolution STL file. This means we'll avoid the coarse setting and select either fine, or even better, we could select custom and leave the angle at approximately 10 degrees, but move the deviation slider around a third of the way down, so it's a little bit higher deviation than fine. Now, once we click OK, it's important to point out that these settings should remain within SolidWorks, so next time you export an STL, it should be set to these custom settings, so you can reuse these settings again. But it's always good to check. So we'll say OK, and then we'll click Save to save the STL. You'll see the triangles that are going to be used to create the STL face on the model in the background. There's going to be a total of 6 files created, one for the clamp side top and one for the clamp side bottom, which are the parts you designed, and then one for each of the fastener components, the nut, the bolt, and each washer. It'll tell you the total number of triangles that are being used, 23,114, and then you'll see the total file size is a little over a meg. So we'll click Yes to save, and it'll save the 6 STL files in your student folder. And if I look in my student folder, I can see these 6 individual STL files created. These can be read by any printer or any other design program, and so they're portable and interchangeable. Now, we talked a lot about settings in the STL creation process, but I did want to review the actual STL creation process is quick and straightforward. You just go to File, Save As, change it to STL type. If you need to set an option, choose Fine or Custom, accept that value, and click Save, and then accept the number of files it's going to provide for you.